Now, if we remove these two constructors, the default constructor is provided by C++ compiler, and then we'll be able to construct this empty string. And in that case, the default constructor will not initialize our string with anything, so it's still potentially dangerous to use it like this. So of course, using constructors is a good idea to provide meaningful ways to create an object and initialize it. Now notice that we never call constructors. So once again, I move this to the side. Whenever there is a way that the object is created, which could be a single variable like this declared, potentially we can declare an array of variables, and then the entire set of objects will be created. So of course, empty constructors will be invoked for it. Whatever the way we choose to create objects, we never call them. Constructor is automatically invoked whenever the object is created. Now this this slide demonstrates a situation where we have three empty classes that's called cylinder, transmission, and wheel. And of course their bodies are empty. So in our case, in the string example, we had the data member, we had constructors, we had some operations. These three classes right here are empty. Okay, so they're just empty. I'll resize this to make it a little bit easier to see. And in case, so empty classes are permitted, and they can be used in various situations, like a tagging or something. Like there could be different ways to use an empty object, but here of course this is done only for demonstration, expecting that in a real application these classes will be populated with something meaningful, like we did with string. And then we create an engine here. Apparently this is kind of like two-cylinder engine with an array of cylinders which is the size of 2. Okay, so we have an engine, the fourth class, and there's a class named moped, or scooter would be another name for it, and it's populated with an engine, with transmission, right, and with a set of wheels, also array of wheels, 2 wheels. Okay, so wheel is also a class. And then we create this moped and give it a name, like Honda or something else. And the object is constructed. So when this object is constructed, the moped, so it will go through the sequence of data members and see how they can be constructed. So this engine contains 2 cylinders. So the engine, if we envision an engine part of our scooter here, will contain 2 objects, an array of 2 objects. I'll try my best to draw these boxes for our demonstration, right? So there will be two cylinders right here, and this is the engine which has an array of 2 cylinders. The next thing that will be constructed is this transmission. Transmission is just a class of its own. So there will be transmission constructed somewhere here. Okay, so there's this object transmission, which is constructed also. And then there's a set of wheels, an array of 2 wheels. So also 2 objects constructed like this, and they will be added here. And then eventually the moped construction will be finalized, will complete, and this will be a box which will contain all of this set of the so-called sub-objects. And the important thing is that it's totally predictable in what order all of this is going to be created. That's the point of this idea that in C++, the order of construction of all sub-objects is totally predictable. So first of all, we're constructing this object right here, and we have a list of data members. And so the first data member is constructed, and it by its definition it contains two of these objects. So this will be number 1, number 2. Those two will be constructed. Then the engine construction will be finalized, and this will be the third object which will be fully constructed. Then we move on to the transmission, which is the next data member of the object that we're trying to create. And of course transmission will be created, so this will be created number 4. And then we have an array of these objects, so their construction will follow. So this will be number 5 and number 6. And finally, the whole rest of this moped, if we had more data members here, would be also constructed, right? So this will be number 7 at the end. And you can see in this sequence diagram that first we're trying to construct moped. So in this sequence diagram, this is the constructor of the moped, which is not here, but we already said that even though constructors are not provided, default constructors are generated for us automatically. So this is where, when we declare this Honda variable, this will be invoked. This is the constructor of Honda. And it will invoke constructor of the engine. And the engine, in the first step, will construct the first cylinder and the second cylinder, because it has two of these objects on its list of data members. And it's predictable. And then transmission will be constructed, and then two of the wheels will be constructed, and then the moped constructor will be done, and we get out of here, right? So we'll be moving on to the next statement right here. So when you define your objects, just expect that this is totally predictable, and it's not very difficult to follow the order. But it's also very good news, because we can really know how to, place all of the variables that are sensitive to what is constructed first, what is constructed next, and make sure that we can, sometimes we may want to rearrange things in different order, but generally speaking, you probably don't want to program things depending on this order. And yet, especially when you're debugging things or you're allocating some resources dynamically, it is utterly important to know the exact order in which parts of objects are constructed. And when we have classes using other classes as their data members, we call them sub-objects. So just very important. This is very important topic in terms of object construction.